Hello children, today we are going to learn about mobility and limitations of Ohm's law. So seeing the term mobility, what comes to your mind? So mobility means ease of movement, right? Ease of movement. So we are dealing with current electricity. Adhanala or metallic conductor eduthukitona, what will move inside a metallic conductor? Electrons. So electrons in a metal conductor, right? Electrons are the charge carriers, are mobile ones in a conductor. If you take an electrolyte solution, electrolyte, we'll write it here, electrolyte. What will be the moving like ions here? Both positive and negative ions. Okay, so different materials will have different types of mobile carriers depending upon the nature of the material. For conductors, it is electrons. For electrolyte solution, it will be positive and negative ions. And if it is an ionized gas, electrons and positively charged ions. Okay. And what is the need for mobility? எதுக்கு நம்மளுக்கு mobility தேவை? எவ்வளவு ஃபாஸ்டா மூவ் ஆகுதோ அவ்வளவு ஃபாஸ்டா என்ன நடக்கும்? கண்டக்ஷன் நடக்கும். So conductivity is basically due to mobile charge carriers. So the faster it moves, the more conductivity happens. So when you take the quantity drift velocity, with the help of drift velocity, you can define mobility as the magnitude of drift velocity per unit electric field. Okay. Mobility is defined by the term mu is equal to magnitude of drift velocity upon electric field. So drift velocity we have learned in the previous classes. Those who have not gone through that, please watch the classes and come back so that it is easy for you to understand. Now drift velocity நம்ம என்ன படிச்சோம்? E by m into tau, correct? Divided by electric field E. So E and E will get cancelled. You will get it as E tau by m. Okay. So, idoda SI unit calculate pannona. How do you calculate the SI unit? You know the SI unit of drift velocity will be meter per second. And the SI unit of electric field is volt per meter. So, it will be like this. Meter second minus 1 per volt meter. In the minus 1, மேல போகும்போ plus 1 ஆயிடு. So it will be meter square volt minus 1 second minus 1. This is the SI unit of mobility. Mobility is nothing. That is a factor that will determine the conductivity of a substance. Okay. The next topic we are going to discuss is limitations of Ohm's law. We have already learned what is Ohm's law, how to write the vector form of Ohm's law in our class 2. Those who have not watched that, please watch the video and get back to this class. So Ohm's law tells us the linear relationship between voltage and current, or potential difference and current. So நம்ம அதுக்கு ஒரு graph வேற போட்டோம். என்ன வரும்? When you take current and voltage, you get a straight line like this. And the straight line will start from the origin. This is the graphical representation of Ohm's law. So in the relationship will hold true for a large number of materials. Many substances under certain conditions of like temperature, pressure. But it is not that it should be always true. எப்பவுமே இது கரெக்டா இருக்கணும், இப்படிதான் ஃபாலோ பண்ணணும் அப்படிங்கிற எந்த ரூலும் கிடையாது. Because it is not a fundamental law of nature. In some conditions, even metallic conductors will deviate from Ohm's law. Okay. So அதுதான் limitations and how that occurs, when that occurs. அதுதான் இப்ப நம்ம பார்க்க போறோம். Before that, we will see a brief classification of conductors conductors are classified into two: ohmic conductors and non-ohmic conductors. Ohmic conductors means it is nothing. They obey Ohm's law. So, relationship between V and I will be linear. A graph will be a straight line and the straight line will pass through the origin. Suppose if I reverse the potential difference, if I make the voltage to be negative, current will linearly vary with regard to the voltage in the opposite direction. That is in the part of the graph. So if the voltage is negative, current will be in this and the graph will again be the straight line and pass through the origin. Appo idhula irundhu ennadhu? R is independent of current through the conductor. R is equal to V by I. இந்த R வந்து எப்பவுமே என்னவா தான் இருக்கும்? Constant ஆ இருக்கும். These type of conductors are called ohmic conductors. Okay, generally நம்ம இது வரைக்கும் பார்த்தா like theoretical and experimental observations will prove this. Lab you would have done a practical first one. So there you would have seen that when you calculate R is equal to V upon I, உங்களோட எல்லா answers will be equal. It should be equal. So because the conductor or the resistance wire that you are using will be ohmic one. Okay. So if the conductors do not obey this, then they are called non-ohmic conductors. So what will happen? This VI relationship will not be linear. The straight line of the graph, VI graph, will not pass through the origin. Okay. So adukku chala examples eduthu we will discuss now. So the first one is an example of a metallic conductor. You can see that from this point till this point, the graph is a linear graph. And after this, it is expected to go through the straight line, but it is deviating. தெரியுதா உங்களுக்கு இந்த deviation? So இது எப்ப இந்த மாதிரி எப்ப நடக்கும்னா normal metallic conductorல when you increase the current increase ஆனா என்ன ஆகும்? Heating effect will increase. அப்ப என்ன obviously என்ன ஆகும்? Resistance வந்து increase ஆகும். So resistance வந்து increase ஆகும்போது VI relationship will not be same. So that it will become non-ohmic. The conductor becomes non-ohmic and it will deviate from the straight line. Okay. So if this is at high increased current, I will not write high current, increased current. So it will not follow the linear relationship. So it behaves like a non-ohmic conductor. So next example is water voltmeter. So here your back EMF will be set up. What is back EMF? You will be studying in chapter electromagnetic induction. So what happens is, as a result of the back EMF, the graph will be a straight line linear graph, but it is not starting in the origin. V0 ingra or point la start agudhu. Okay, so this is a non-ohmic conductor. VI graph, even though it is a straight line, but it passes from some other point other than the origin. Okay, so for this is, that is, if this is 0, this is the origin, this is a point with the increased voltage. Water voltmeter, this will be equal to 1.67 volts. Okay, so the graph starts only at 1.67 volts. Till then, there is no like variation of current with regard to voltage. Okay, so this is another example for non-ohmic behavior. Okay, coming to the third example, PN junction diode. All semiconductor devices exhibit non-ohmic behavior. The reason is they start working only after a particular voltage application. Okay, so the one example is PN junction diode. Here this is the forward bias, the reverse bias. So the variation of voltage and current will not be linear. This is thyristor, another device which uses the principle of semiconductor. So here also you can see that the graph is not linear. V and I graph is not linear. This is a semiconductor material which is gallium arsenide. Inga pathingana, you get the same current for different voltages. In the voltage you get the same current. In the voltage you get the same current, which is a non-ohmic behavior. So all semiconductor devices exhibit non-ohmic behavior. Metallic conductor exhibits non-ohmic behavior at high currents. So the inferences will be as a result of non-ohmic conductors, finally, the voltage will stop to be proportional to I. Okay. And relation between V and I depends on the sign of voltage. That is in a diode. Diode, if you can see, here the variation is different. Here the variation is different. This is the negative voltage characteristics and this is a forward bias, reverse bias we call it. Okay, RB, FB. Okay, you will be studying this more detail in chapter 14, semiconductor devices. The relation between V and I is not unique in gallium arsenide. I told you already, you get two value of current for different voltages. So as a result, this is non-ohmic. Okay. So summary of this will be conductors behave as ohmic conductors till a particular value of current. After that, they become non-ohmic. Semiconductor devices are non-ohmic. So they exhibit non-ohmic behavior. Okay. I hope you have understood the concept. Please stop and take notes whenever required so that it is easy for your future reference. If you have any doubts, please raise to us in the comment section. We will be happy to help you. Thank you.